All right, let's turn to the problem set on confidence intervals. And as you can see, I also opened already an Excel sheet, and we can use Excel to identify like critical T's and areas under the T distribution. But most importantly, we will use it to program the entire steps of answering questions in a way so that you just need to input the relevant information and then you get immediately the answer. And that in itself is a valuable exercise. But yeah, we'll do that once we get there. So let's first start with a couple of easy questions that we will calculate by hand. So when establishing the confidence interval for the average weight of a cereal box, assume that the population standard deviation is known to be 2 ounces. And based on the sample, the average weight of a sample of 20 boxes is 16 ounces. So the appropriate test statistic to use is, in this case, the z-score. Why? Because we know the population standard deviation. And T, X, and P, those are not really distribution. I mean, the T is, but not the X and the P. At least I don't know about an X distribution. As the stated confidence level decreases, the width of the confidence interval stays the same. Now, decreases, increases, disappears. And of course it decreases. And why is that? If you remember a confidence interval, let's say, if you visualize it, it's easier. So we have a sample, and around that sample we essentially build the confidence interval. So we have here our sample mean, and we have the standard error, which is the standard deviation of the sampling distribution, which is the sample standard deviation over the square root of n. But if that is all the same, so let's say we have the same sample standard deviation and the same n, so that is the same. Well, if you have, for example, the 95% confidence interval, then we will get this range. So then we will get this range. And if we go to a 90% confidence interval, well, the range becomes obviously much smaller, holding everything else constant. The weight of a product is measured in pounds. A sample of 50 units is taken from a batch. The sample yielded the following results. X equals 75 pounds, but we know that the population variance is 100 pounds. Calculate the 90% confidence interval for the population mean. Okay, so at this point, I think we can start actually coding or programming this answer, and we can use it for other purposes. So what we need is, when it comes to confidence interval, we have to answer a couple of questions. I call that the input panel, where we need to enter our information that we have, and there's a certain value with it. Okay, so here the first question would be, what is your sample mean? What is your sample mean? Question mark. Okay, so now here we can enter that the sample mean is 75. And we also need to know how big is the sample. So how big is the sample size n? And in this case it is 50. So we already know it makes a big difference whether we know the population standard deviation or not. Whenever we know the population standard deviation, we can use the z-score, and if not, we have to use the t-score. So the next question would be, do we know the population standard deviation, just abbreviated SD, question mark. So here we shall let a user enter yes or no. The way to do that in Excel is we have to add there a drop-down menu which has the values yes or no. The way we do that is we want to have now, in my case in cell B4, a drop-down menu, and actually zoom up quickly here. And the way we do that is we go to data, and then there is a field called data validation. Click on this one, data validation, and then where it says validation criteria, we say list, and then what is the source of the list, and we highlight where we entered the yes and the no. And now you see we have here a drop-down menu that says yes or no. And if we don't like that list to be shown on the same page, we can just cut it with Ctrl X and park it in another sheet. And then the drop-down menu is still there. So in our case, we do know the population standard deviation. Yeah, let's center everything. So we know this population standard deviation. So then the next question should be, what is this population standard deviation? But we do that, so we put here the question, which is a function of whether the person says yes or no. So when the person who gives the input knows the standard deviation, we should prompt the user to set with the question, what is the population standard deviation? So the way to do that is to say if, and now we go and highlight the cell where we have the drop-down menu and where it currently says yes. And if that cell is equal to yes, then prompt the user with the question. So we enter next a comma, then prompt the user with the question in quotation mark, what is the population S.D standard deviation, question mark. And then we close this with quotation marks, and then we say comma, or we enter a comma, and that Excel wants now the value if false, which is if it's not yes, well then it is no, and then we prompt the question, what is the sample standard deviation? And again I abbreviate that with SD, question mark. Okay. So now depending on what a user enters, knows the population standard deviation, yes, then the next question is what is the population standard deviation? But when we say no, then it changes it to what is the sample standard deviation. Okay, but in this case we know that the population standard deviation is given, and actually what is given is the population variance, but we know the standard deviation is the square root. So we have to use the square root of the variance of 100, which is 10, and we can enter that. Okay, so the next question we need to answer is, which confidence level do we want? What level of confidence do we want for the interval? So in this case, the level of confidence is 99%. So we ask the question, what is the level of confidence in percent? Okay. So in percent, we want the 99. So that should be everything that a user should enter. That should give us all the information that we need. Now we can format it a little bit nicer. Input panel, value, and those fields are essentially input fields, and there is something we can do in Excel. When we go to the home button, there is cell styles. We can say to format these cells as an input cell, but you can use any other design that you like. Okay, I think this is everything that we need. So we have the sample mean, the standard deviation, the n, whether the population standard deviation is known or not, and the level of confidence. So now we can move to the output panel where we present the results. Output panel, and again we have the value. Okay, so the user probably wants to know what is the t-score that goes, or the z-score that goes into the confidence interval. So if you remember, the confidence interval for, let's say, X% confidence interval was given by the sample mean plus minus, and then it's either the t alpha half or the z alpha half, when we know the population standard deviation, times the standard error. Well, when we have to work with the t, we know the sample standard deviation over the square root of n, but if we know the z, or when we can work with the z, we know the population standard deviation sigma. So the width depends on whether we know the population standard deviation, yes or no. But we can call that. So what the user may want to know is what is actually the critical t or the critical c, which goes into the formula. So this is either the critical t or the critical c. Critical t or z. So whether it's the critical t or the critical c, that depends again on whether the user said we know the population standard deviation, yes or no. So we say again, if, okay, the answer to do we know the population standard deviation is equal to yes, comma, then, so the comma means then. So if the user said yes, then we prompt the user, or then we return your critical or relevant z-score is, and then maybe colon, and then we close the text with the quotation mark. Otherwise we will say your relevant t-score is, your relevant t-score is column. Okay, and then we close with the quotation marks and parentheses. Okay, so now because currently it says yes, the output panel will say your relevant z-score is. If we switch that to no, then it says your relevant t-score is, and it switches also to the sample standard deviation. Okay, so now we can answer. So now we can determine whether it's a t-score or a z-score and identify the relevant one. And again, remember the alpha half is, so if you want to have a 99% confidence interval, we have to find either the relevant t or the relevant z, to whose left or to whose right we then have 0.5% probability. Okay, so that means we have here to the left 0.5% in this area, or here also 0.5%. So the way we can do that now in Excel, we will say, again we need an if, because it depends whether we know the population standard deviation or not. So we will say equals if this answer to the question, do we know the population standard deviation, is equal to yes. Then we have to use the z-score. Okay, how do we find the z-score? The z-score is given by norm s.inf. Okay, so now we need the probability. So we need the area to the left, where we need the z-score to whose left side we have 0.5% probability mass. But we need to get that as a function of the stated confidence level. Okay, so now what we do is we can say this is equal to 100 minus the stated confidence level. And let's just click into the cell where the user inputted that. So now we have 100 minus 99, which is 1. Okay, so let's put that into parentheses. And then, so that is 1, and now I need to divide that by 2. So now I have 0.5, and I have to divide it by 100, so that we get 0.005. And that should be it. Okay, so that should give us the relevant z-score, and that will be a negative value. And we will later switch that, make sure that it's just a positive value. Okay, but if the user says no, then we have to use the t-score. And for the t-score, we have a similar formula, but we need also the degrees of freedom. So then we would enter t.inf, open parentheses. So now the probability is again determined by, open parentheses, 100 minus the confidence level, 99, then divided by 2 and divided by 100. Okay. So now we need to identify the degrees of freedom, and we know that is equal to the sample size. So I click to the answer next to how big is the sample size, and I subtract 1. And then we close that formula. Okay, so degrees of freedom Okay, so now there's probably a parenthesis missing, norm as inf, open parenthesis. Oh yeah, of course. So we need to close it here, and now it should be fine. Okay, so now we get negative 2.75, and you see if the user would have said we don't know the population standard deviation, it automatically switches to a different score, but that's the t-score. So maybe we want to limit it to, we want to make that absolute and limit it to maybe 3 decimal points. That's good enough. So we go back to the formula and we put around an absolute. So the formula is ABS, absolute. Okay, so now there's no negative sign. And then we also want to round it to 3 decimal points. So we can say, or we can just actually format it in the formula. We can right click and then we can shift at the symbol that says decrease decimals, switch it to 3 decimals. So now we have the relevant z-score or t-score. And then the next question is, so now we want to say your lower 99% confidence limit is, and your upper 99% confidence limit is. So we can now write your, so we have to put that into, we start with an equal sign and then in quotation mark, your lower. So now I need to pick up the confidence level that the user chose. So that means I stop the first part here and I close that with quotation marks. Now I add the end sign, which is above the 7 with shift, and we pick up the confidence level that the user input that provided in cell B7. So we just click there, and now it says your lower 99, and then we add again text. So we need to add again the and sign in quotation marks, space, and then we can say lower or 99, maybe we say percent confidence lower limit is. I don't know if that's a good sentence, but I think we get the point. So now it says your lower 99% confidence lower limit is. That's not that bad. And so maybe we can even do it like this. No, we can't. Your lower, okay, percent okay, so now it looks a little bit nicer. And now we can do the same thing for the upper. So I copy and paste this formula down. You can copy down in Excel with Control D, and then we just change your lower, and you have to change the cell B7, go back to 99, and now it says your lower 99%, but we have to change that to upper. Your, well, actually that was too much language. It's just your 90% confidence lower limit is, that's good enough. So we have to delete again some words. Okay, I think this is clear now. So now we have your 99% confidence lower limit is, and below we have to change that to upper. Okay, that is just like cosmetics. Okay, so now we just can enter the corresponding formula. So the lower limit is equal to, so we enter equal, we go to the mean, and then for the lower limit we do minus the relevant z-score, the 2.576, times the standard error, and the standard error, we could actually make a separate information for that. So I enter another row and I say your relevant standard error is, and we know that the standard error is always equal to the standard deviation divided by the square root. The Excel command is sqrt of the sample size. So that is B5. It's actually, it should be B4. That's where we have the standard. Hold on, do we know? No, it was correct, B5. So the population standard deviation was 10, and we divide by the square root of B3, where we have the sample size. Okay, so in this case, the standard error is 1.414. And now we can do the lower and upper limit, which is equal to the sample mean. So the lower limit is then minus the 2.576 times the standard error. Okay, and then we limit it again to maybe 3 decimal points. And then we calculate the upper limit, which is equal to the population, to the sample mean, plus the relevant z-score in this case, times the standard error. And we limit that also to 3 decimal points. Make it look a little bit nicer by formatting everything. Okay, and now this is basically an output. We can say that cell style is an output. Okay, well, so that's an investment that probably will come in handy for the next question. So the question is, calculate a 99% confidence interval for the population mean, and the lower limit is 71.357, so that's rounded, probably 36. So the answer must be A. Okay, but now you see we have another question. A random sample of size 15. So now, sample size, we just use our template, we enter 15. Is taken from a population assumed to be normal, and X bar, the mean is 1.2. So what is our sample mean? 1.2. And the sample standard deviation, so now we do not know the population standard deviation because we are given the sample standard deviation, so we change this to no. And the sample standard deviation is 0.6. So 0.6. And now we would like to calculate the 98% confidence interval. So we change the level of confidence to 98. And now voila, we have the answers. So it goes from 0.793 to 1.6. And that will actually be, the numbers are a little bit different after the third, because I believe those numbers were calculated with not as precisely as we do it here. So there were probably some earlier rounding issues. But if you went to 2 decimal points, it would be clear that this must be the right answer. It would be 7.9 and 1.61. So if there's like a minor difference, it's probably because the answers have been calculated differently. Okay, so now we have another question. In a manufacturing process, we are interested in measuring the average length of a certain type of bolt. Based on a preliminary sample of n equals 9 bolts, the sample standard deviation is 0.3. Okay, so let's get this information here. The sample standard deviation is 0.3. That's an estimate. And our sample size is n equals 9. And the question is, how many bolts should be sampled in order to make us 95% confident that the sample mean bolt length is within 0.02 inches of the true mean bolt length? Okay, so here our template doesn't really help, but what we need to do is we have to first acknowledge that the 95% confidence interval is given by, okay, the sample mean, and now plus minus, okay, the t-score, where alpha half, meaning in each pocket we have 0.025 times the standard error. Because we only have a preliminary sample standard deviation, we have to use this as equals 0.3 over the square root of n. Well, this question is now asking for how many n do we need. So the point here is, the greater is the sample size that you have, the more representative the sample is, and the smaller is the standard error. So that means the less variation is there essentially around the sampling means. So you get a better estimate. So in this example, the mean is actually irrelevant. What we want is that this range, this plus minus, is within 0.02. So this entire term should be less than or equal to 0.02 inches. So this is what it means. So the only thing that we really need is we need to get the t-score for how many degrees of freedom? Well, because we have n equals 9, our degrees of freedom is 8. So now we can quickly use Excel to tell us that t-score, let's go to maybe quickly another sheet, and we use the formula equals t dot inf, open parentheses, the probability that we need is 0.025. How many degrees of freedom do we have? 8. Okay, so now we get 2.306. So our relevant t for here is 2.03 roughly, or rounded to 3 digits. So the relevant t equals 2.306 in absolute terms, because it's plus minus. Okay, so now what we need to calculate is, or basically what we need to solve is the equation 2.306 times the sample standard deviation of 0.3 divided by the n. And I need to know this n that makes this term less than or equal to 0.02. Okay, so now if we rearrange this equation, we see that n, I can put that on the other side, and well, let's first put the square root of n is then equal, or actually greater than, I put it on the other side, and I divide both sides by 0.02, so I get 2.306 times 0.3 divided by 0.02, and here actually the sign was wrong, because if I put the n on the other side, n must be greater, so it should be like this. But then I need to square it, so I need to get rid of the square root, so I delete this again, but then I need to square this term. Okay, so we can actually do that quickly in Excel. So I first absolute this one, so I put an absolute around the negative 2.306. Okay, now I multiply this term times 0.3, and then we divide by 0.02, and then I put again parentheses around and I square it. Okay, so now what you see here in Excel is exactly this formula. And now we get 11,960.47, and if we round that, that's 1,197, I mean. And that's the correct answer. So if we round this one up, then that sample size will shrink the confidence with, even though it is still a 95% confidence interval. So what's important is to understand is to see that even if I have the 95% confidence interval, a 95% confidence interval based on a higher sample, on a bigger sample, is always smaller than a 95% confidence interval based on a very small sample. Okay, so question 6. A researcher collects a sample of 25 observations from a normally distributed population with an unknown standard deviation. The sample mean is 48 and the sample standard deviation is 10. Which distribution should be used to construct the confidence interval for the population mean? Well, it's an unknown standard deviation, so that means we have to use the t distribution, and specifically with n-1 degrees of freedom, so the correct answer is t distribution with 24 degrees of freedom. A hospital administrator wants to estimate the average length of patient stays. A random sample of 36 patients yielded 5.4 days and a sample standard deviation of 1.8 days. Calculate the 95% confidence interval for the true mean length of the stay. So this question, which I got from somewhere, probably the textbook or so, they have a rule that says whenever your sample size is greater than 30, even if you don't know the population standard deviation, you can use the z-score, because at the higher sample size, the t distribution approximates the standard normal. But I don't recommend really doing that, but I want you to know that you find that in some textbooks. I would use the t-distribution, and the good thing is we can actually check now whether this is equal to 1.96 because we have the accurate values. Okay, so we have an n of 36 and a sample mean of 5.4. So let's enter that, 5.4. How big is the sample size? 36. The sample standard deviation, so we do not know the population standard deviation, so that stays a no. So the sample standard deviation is 1.8. And we want to have the 95% confidence interval. And you see that the true relevant t-score is actually 2.03. But the exercise said it should be 1.96. So if we pretend that this is actually a yes, you can see this is where the number comes from, but there's a slight difference. So I know many textbooks recommend that, and we can follow this one. We can just assume, yeah, this is the population standard deviation. So now we go from 4.81 to 5.99. So A is the correct answer if we are told to use the z-score. But technically this is not right. The true answer should be actually this one, using the t-score. So yeah, it's still very close, but it is actually slightly different. Okay, so so this is just to alert you that you sometimes will see people say, oh, the sample size is greater than 30, you just can use the z-score. Yeah, I don't think this is a good way to do it. If you can do it accurately and you can calculate it with the t-score, just do it. And today with the use of Excel, there's really no need not to resort to the t-score. Okay, all else equal, if a researcher doubles the sample size from n equals 50 to n equals 100, the width of the confidence interval will, I don't think it will be cut in half, but it will be definitely reduced. And it will be reduced by approximately 29%. Okay, is that something that we can maybe, yeah, we can calculate that. So let's assume we have a 95% confidence interval. Okay, the width of the confidence interval, good. So again, a confidence interval is generally written as confidence interval sum equals sum x bar plus minus whatever t we have times whatever sample standard deviation we have over once 50 and once 100. So let's keep it actually simple and let's use a trick. Let's assume t is 1. And let's assume the sample standard deviation is 1. So this is also 1. So then we get x bar plus minus 1 over the square root of 50. And of course, if the sample size is 100, then we get a confidence interval which is x bar plus minus 1 over the square root of 100. Okay, so let's just compare those two values quickly. And I'll just, okay, so let's call this one n equals 50. So then we have to calculate 1 divided equals, I forgot, equals 1 divided by the square root of 50. Okay, so that's 0.14. If I have a sample of 100, the sample standard deviation, I can actually calculate in my head, it's 0.1. Okay, so now we can see that the width, holding everything else constant, has dropped from 14 to 0.1. So how much of a reduction is that? So the percentage change is, okay, so how much smaller is that? So we calculate the percentage change. So the percentage change is given by, okay, so if we increase it, so we have the new value, so the percentage change is the new value, 0.1, minus the old value, which is the 0.1412, divided by the old value. That gives you the percentage change of the new relative to the old. Okay, and that's negative 0.29, so it's roughly 29%. Okay. So, question 9. A sample of n equals 10 is drawn from a normally distributed population with unknown sigma. Okay, it looks like we can use again here our template. So a sample of n equals 10. How big is the sample size? Now we enter here 10. And with unknown population standard deviation, so that stays a no. The mean is 22, so let's enter that, 22. And the sample standard deviation is 4. And we would like to know the 90% confidence interval, so let's enter 90. Okay, 22, sample size 10, sample standard deviation 4, 90% confidence interval. And in this case, the question already gives us the 1.833, but we also see it here. So now the answer is, it goes from 19.68 to 24.3, so the answer is A. Okay, let's do still 10 and then let's make a break so that the video doesn't get too long. That's already very long. So a quality control engineer wants to estimate the mean diameter of ball bearings to within plus minus 0.05 millimeter with 90% confidence. Prior data suggests that the population standard deviation is 0.2. What is the minimum required sample size? Okay, so this is a similar problem to the one we did earlier. So we want to know the 90% confidence interval. So 90% confidence interval. And we want to make sure that when we write it out, the plus minus sigma, which is 1.645, because if you have a 90% confidence interval, again, remember, that means we build around our mean, 90% confidence. That means we have in this pocket 5% and in the left pocket 5%, which is 0.05. So that is 1.645. We can double check quickly. We just say this is, okay, let's delete this one here. We say equal, so now when we know the z-score, we use norm as inf inverse probability 0.05 and this is the negative 1.645. Or if we absolute it again, we put an absolute around. And the equal sign we get 1.645. Okay, so it's rounded 1.645 times the standard error. So the population standard deviation is 0.2 divided by the square root of n. And again, that is supposed to be less than 0.2. So let's rearrange terms again. We can write n needs to be greater or equal. Okay, so the n, put that on this side, and I divide and I put that on the other side. And actually I made a mistake. Hold on. Prior data suggests, oh, this is not 0.2, this is supposed to be 0.005. Oh. Okay, so, and the 0.05 goes into the denominator of 0.645 times 0.2. So we have then 0.645 times 0.2 divided by the 0.05. Okay, but then I need to square it. So that means we square both sides. Okay. And I just can continue here in Excel. This is equal to this times 1.645 times 0.2 divided by 0.05. And now we put that into parentheses and we square it. And now we see 43, so there should be an answer 44, which is A. Okay, so maybe let's stop here. And I think this, I hope this has clarified now how to construct confidence intervals. And I also hope that maybe this little Excel programming exercise was useful. But let's just stop here, because the next question referred to the confidence interval for the population proportion, which is similar but slightly different. But let's just stop here for now, and then I'll see you in the next video.